from the UK, and certificate 1 is an optimum SSL cert from the United States. And these two separate entities, or two separate organizations, have the same key in their cert. So maybe they own each other. They have simultaneous expiration, so it seems like they're designed to kind of be considered valid for the same period of time. The business interests of these entities are obviously intimately aligned because they're sharing key material. So they have the same SCIDs and AKIDs and key usages. It's a really weird thing. Whenever you have two countries or two organizations with one public key, it's kind of a fun example to look at because you know that there's something going on here. And the issuing authority here is USERTRUST. So obviously, whoever that is, they're cool with those two people being sharing their private keys. So here's another example where we've got 3 different certificates, all sharing a key. The 2 SHA-1 fingerprints of the certificates in question are, oh yeah, sorry, so those SHA-1s are just the SHA of the DIR encoding, so you can look them up. You've got 2 different countries here and 2 organizations with 1 public key. The issuing authority is, interestingly enough, USERTRUST again, and so we've got this positive software in Comodo now sharing stuff across countries with their light SSL. The neat thing about this is that certificates 1 and 2 expire in 2020, and number 3 expires 10 months earlier. 2 and 3 actually share start dates, but over 44,000 certs are using this key ID. So some CAs are using these shared keys to delay the expiration of their certificates. So just looking from number 2 here, you can tell that this short key has been used before and how long it's been available to attackers. VeriSign had a 1024-bit key shared by 4 certs with a total lifetime of 7,000 days. When extensions were created for that key, the new key was kept like at the old start time, so that examining trust roots would give the user an accurate understanding of how long the attackers have had to brute force this key. It's not a very strong key, it's only 1024 bits. The key start date is from 1997, which is before AKIDs and SCIDs started showing up, those key identifiers that make validation more efficient. So this little trick here is adding 2,392 days to this key's lifetime, which was only supposed to be 6,000 days originally. So kind of, I don't know if that's bad, but it's interesting. And it's a policy decision that you can only sort of start thinking about when you look at all the different keys that are out there and all the subordinate keys. And the subordinate keys aren't always visible to you because when you look in the trust roots, it doesn't tell you what all the subordinates are. All right, I want to do this one too. So one of my little bugbears is that when you're using SSL, you've got this idea. You've got a user that wants to connect to something, and they should know kind of what that is. Like maybe I want to talk to Google, or maybe I want to talk to EFF or to Peter, right? So there's a meeting of minds though between the certificate authority that asserts that Peter is who he says he is, and Peter, right? So I connect to him. This RFC 1918 defines our nice little reserved IP addresses like the 10 and 192.168 space. There's CAs out there that are handing out these addresses as certs. So they're saying, oh yeah, you're the real 192.168.2.1 or .1.2. So US Equifax asserts that that address is in Texas, and Belgian GlobalSign actually puts it in the US too. Oh, but also in the UK and in Switzerland and in Belgium. Oh, and it also says that that's also 77.76.108.82. So you might not have known all that. Anyway, I think that's a terrible thing when you see people signing IP addresses that are in reserved spaces. They also sign unqualified names, and that's kind of cute. We found one CA was signing, Comodo signed like 6,000 of these localhost certs. And this is actually the most common valid certificate on the internet by name, localhost. And some CAs, like CyberTrust, Entrust, Equifax, and Microsoft and VeriSign, actually only signed one cert that we saw with the name localhost. Almost like they kept track of the names that they were assigning, which means these other ones obviously.
Yeah, of course. In addition to localhost, you've got mail and lots of other kind of natural LAN names that shouldn't really be the subject of certs. So Yeah.
Some countries aren't even using their own CAs. So we found that Macau has its own 2048-bit CA that's in XP, but it doesn't use them. It doesn't even use a Chinese or a Portuguese CA. It uses, it signs its government's websites with commercial certificates from US and UK companies.
So there are some funny weak certs out there. There are some that have 508-bit RSA keys. Just a couple of those, but they were valid. Those are the fingerprints, or at least portions of them. And there are some vulnerabilities and other weird things. So the biggest thing we found, what we did is got a table of the blacklist of keys that resulted from the Debian OpenSSL bug. Debian had this bug that was present from 2006 to 2008 where their random number generator in SSL wasn't functioning correctly because of an attempt to fix a bug that wasn't really there. The end result was that only 15 to 17 bits of entropy in OpenSSL's keys on that platform at that time, which means that those private keys are not private. You can just go and make a list of them all. They're public private keys. So if you see one of these keys in use on the internet, it means that anyone can just go and jump into that SSL session and start messing around. And so here's a little query effectively that tells you, select subject from certs, join against the blacklist, where the SHA-1 of your cert is the same as the hash in the blacklist. And what do you find? Well, there are 28,000 certificates on the internet that have this bug in them. 28,000 certificates where the private key isn't private. Fortunately, only 500 of those 28,000 are actually valid. So we're not talking about quite as much of a problem. But of the other 28,000, 12,000 of those are CA certs. So unfortunately, probably what's going on with some of those is that they're being used for private PKIs inside organizations. And those organizations need to really replace their infrastructure really quickly. Well, 2 years ago. It's sort of bad that this is still happening. And really, okay, people can be excused for messing up and using an old version of something on their machines, but CAs cannot be excused for signing certificates for known weak keys. And they can't be excused for failing to revoke the certificates they've signed when they have a straightforward list that they could check against. Now, there are some CAs that did okay by this measure. Starfield, 5 out of 5, revoked the certificates that had the blacklist keys. Comodo got 29 out of 30. I don't know what happened to that 30th one. It's actually kind of an important server. I'm not going to say anything about what it is but until it's fixed, but it's kind of bad that that 30th is there. USERTRUST similarly. And some CAs did a really bad job. Equifax, none out of 140 of the weak keys were revoked. CyberTrust got 4 out of 125, which presumably means they were revoked for reasons other than the weakness of the key, etc., etc. So we just discovered this a day or two ago as we were finally cramming our slides together. Once we've had time to contact the people who need to switch out these keys, then we'll be ready to actually publish the database. We don't want to do that before that's done. There are also some other weird kinds of certificates out there. If you go looking at, like, all sorts of other queries you can ask and you get something strange. So here's an example of one. This is a slight stylization of the SQL query, but it's approximately how it works. And what it's asking is, it's saying, do valid certificates agree? There are 2 parts of a certificate that pertain to whether it's a CA or not. Actually more, I'm simplifying when I say there are only 2 parts. But there's one part that says, am I a CA, true or false? And there's another part that says, what is this key used for? And one of the flags that can be in the key usage field is signing certificates. And so these 2 fields should agree. There is precisely one valid certificate on the internet where they do not agree. It's a certificate that's marked as not a CA, and yet when you look inside the key usage field, it says it's allowed to sign certificates. Now, I have no idea whether all clients process the certificate correctly. Perhaps they do, but it should never have been signed in the first place. It was signed by Quivadis, the CA based in Bermuda, and I guess they do things liberally in Bermuda. So we decided also to create some pretty pictures of the set of CAs and which ones sign subordinate and intermediate CAs for each other. What does that look like? And so feed all of that data set into GraphViz and you get this.
That's not pretty.
It's not pretty and it's kind of hard to see on this screen, so maybe we can try to zoom in. That's not even a root CA, that's an intermediate CA that signed a lot of things, mostly universities in Germany, 247 of them. But you still can't see very much. You couldn't see what that name was from this graph, but you keep zooming in, it's hard to see what's going on. So if we have time, which we probably won't, maybe in the breakout session, we can let you zoom in and fly around this graph and see all the gory details.
Yeah, there's a lot of complicated things here, and it's not very instructional, unfortunately. But we can sit back and take a look at some of the more interesting subordinate CAs. Some of the ones that we saw that we thought were kind of cool was I didn't know that the DHS had a subordinate CA cert, and it does, and that's it operates an organization. I'm sure they signed up all the paperwork, and we didn't see them doing anything abusive with it for sure. But it's interesting that they had that. I didn't know that I was trusting them. CCNIC, I mean, I know that I trust them, but I didn't know I was trusting them in my browser. Yes, that's what I meant to say. Then there's also the CNIC, which there was
It is CNIC, that's mistyped.
That's right. That had this subordinate CA that in 2009 that got added to the trust root, and a lot of people got excited about it. And it turns out that we found it had been signed by a subordinate CA in 2007, so you already trusted it before you had the whole fight over whether or not you were going to trust it, so that's good. Then there's this company,
Eckersley, which is a company in the United Arab Emirates. This isn't our discovery at all, thanks at least to Chris Segoy and maybe other people before that for observing. This company was known to have installed malware on the Blackberries of 100,000 of its customers. And yet it's trusted by all of the world's browsers to sign any domain. And it's not trusted explicitly, it's trusted indirectly because other people have signed it.
So you send a little malware, and then people keep bugging you about it for years. It's terrible, poor guys. Anyway, UAE doesn't otherwise have any CAs operating in its country too, so that's its court's like little wedge on signing stuff. So great. Boozell and Hamilton. I like them because I met a cool guy there at a conference, and he was giving a great talk about how you can use web attacks, and because he does that for his work, and it's good. But don't worry, he's doing it for the government, so it's all legal. Gemini, they're an observatory, and hey, I want a CA cert. That'd be cool. And then lots of
we're an observatory too.
Yeah, totally. Come on. So companies, Dell, Ford, Google, Marks & Spencer, Vodafone, some of those, it makes a lot of sense that Google has a CA cert. They have a lot of stuff on the internet, and but Ford, I was a little surprised by that one. And then there's hundreds more. It's kind of fun. So subordinate CAs, countries with valid CAs. We saw about 46 countries with valid CAs. The most prominent by CAs were the United States, South Africa, because of thought, the UK, Belgium, Japan, Germany, the Netherlands, and Israel. Those top 10 countries each had over 10K valid certificates that we saw that were signed with their certs. Through subordinate CAs, the following countries didn't appear to have a root CA, but they kind of gained a CA. So the UAE doesn't have a CA for its country, a root CA, but it has a subordinate CA in its jurisdiction. So maybe its courts can ask them to give them little spying permission or something. Same with Iceland, Luxembourg, Macedonia, Malaysia, and the Russian Federation. Yeah, so 64 roots didn't include a country. Most of those are probably US based. If you have a big company in the US, maybe they don't feel like they have to say what country they're in because they're big. And then a little bit about the unwashed self-signed masses. So some people choose to use self-signed certs, and it's arguably quite reasonable. If you don't need a trusted introducer, why pay for it? And then adopt all that complexity of the CA infrastructure. The cost and complexity of the model should then be lower, and it's already widely used for SSH, which is what we use to install our certs. So in principle, it kind of reduces your attack surface by eliminating the risk of random subordinates or trust roots asserting that they're your webmail server. In practice, though, it's a lot trickier. For one, certificates can have multiple names, And we wouldn't want to have to, or take one from one website and have it used on another. Modern browsers like IE, Firefox, and Chrome all track what sites self-signed certs were approved for. So even if subject alternate names also want to approve star.google.com or some other sensitive domain, the cert won't be accepted for those.